Okay, hello everyone, and we're here for the week 5 of Office Hours. This is Unit 4 in as you're proceeding along in the agent-based modeling MOOC, and we are this week starting one of my favorite chapters, which is the chapter on how to build an agent-based model. And the reason why this is one of my favorite chapters is because this chapter is essentially kind of the thing that got me really involved with putting together both a textbook and a course in this space, right? And how it came about was that Uri Walensky and I I was a postdoc for Uri, at Northwestern, and we were actually doing a number of different workshops on agent-based modeling. And when we were doing those workshops, we realized that the material that we were using was really interesting to people, and it was a good way to teach the class. And so we eventually decided we would write a textbook out of that material. So we're on week 5. This is Unit 4, and what's up already is content about how to create agent-based models, and specifically how to design them. And then in the next couple of days, we'll be talking about how to actually build the model that we're designing. And then finally, at the end, we'll talk about how to analyze the results of the model. So the nice thing is that this unit, this week, in some ways, is kind of it encompasses all of the agent-based modeling componentry that there is, right? But what we'll be spending, and of course, if that was all there is, we'd be stopping at that point, but we'll be spending the rest of the course actually going over all the details, because there's a lot of details in the meat of what we're going to talk about. Anyways, and so you'll get little glimpses into things we're going to talk about later in the course, right? You'll get little glimpses into how to create agent sets, for instance, which is an important notion within NetLogo, and also an important notion within agent-based modeling as well, how to filter down to the groups of agents that you want. You'll get a little notion about how to analyze your data in R, right? And we don't have time this week to look at all the possible ways to analyze that data, but we will talk about that in more detail in later weeks, right? And so as a result, I think this is a very important and critical week. It turns out also that we'll have some interesting surprises at the end of the week. We're going to have a guest speaker who I think will be a great benefit to what's we're talking about this week. And we'll also do our first homework assignment that is based upon a peer review. And essentially, just to give you a little heads up for those of you watching the office hours, the idea here is that you will take, now that we've gone through kind of some of those design notions, I'm going to have you revisit that questionnaire that you did at the very beginning, and I'm going to have you submit it to peer review. And when you submit it to peer review, what happens is that all the other, a group of other classmates, not all of them, but a group of your other classmates will then see that design, and they'll be able to comment on it and provide you with some feedback as to what's going on with it. But this will actually be a great assignment, so you have to actually fill it out completely, and it counts just as much as one of the tests does. And you'll see that at the end of this week. Other than that, a couple of other quick announcements. Number one is that I've been finishing up, kind of putting the final touches on the Unit 4 material. I have it all kind of recorded now. I'm just kind of editing it down and getting it all together. But one thing about it is that it's made me realize that it's longer than most of the other weeks. And so as a result, Unit 4 may spill into week 6 a little bit, just to give you a little bit of warning along those lines, depending upon how the content works. The other announcement I want to make is that there is a hard deadline coming up for the tuition, and that hard deadline is September 1st, which is this week. And the reason why that's a hard deadline is because from here out, we're going to be working with we're going to be doing at least 2 and maybe more peer-reviewed assignments for the final project. And because of the nature of that, right, because of the fact that we need to know whether or not you're completing the course or not as part of this course, we want to have a deadline of having September 1st for those assignments. Okay. So those are the major announcements I had this week. I'm going to kind of grab a couple of the questions that were sent in during the week. and we'll talk about a few of those. We had a couple of people who were going to join the office hours, but none of them have clicked on the invite that I sent them. If you're out there and you're listening, you may actually see 2 invites to the office hours. One is a viewer and one is a participant. But you have to click on the right invite in order to actually get into the office hours so that I can actually hear you and talk to you. Otherwise, you're just viewing the office hours. And everyone, of course, could view the office hours, okay? So let me know if you're having any troubles with that, and I'll try and debug as we go. Otherwise, sorry about that. Otherwise, we'll just go along as is. So I had a question from Jay Simmons, who says he'd like to know, or they'd like to know, how far analysis of ABM can be taken, also going beyond traditional statistics and time series. When the micro-macro effect is spontaneously emergent and self-organizing, some have recommended bifurcation analysis of mean-described complex systems attractor dynamics. This technique is, of course, borrowed from dynamical systems, so the modeling perspective should be made amenable to a dynamical systems framework. Observing the system entropy as a complexity measure is also possible, and the self-organization could be defined with this, as already mentioned in one of our previous office hours discussions. There's also hints of more exotic methods for typical situations, at least, such as linear stability analysis, mean field approximations, and renormalization group analysis. These techniques are probably beyond the scope of this ABM course. They are, for the most part. We'll talk a little bit about some of them, although some participants are at PhD level, but from diverse backgrounds, right? So yeah, so most of those will be beyond. We may allude to them in the chapter unit 6 when we talk about analysis of ABMs. But it then goes on to say, I've connected R with NetLogo using the RNetLogo add-on, and this has proven to be useful for deeper analysis. I also believe NetLogo can be used for much more scientific investigations. Yes, in fact, you know, just a brief aside, I recently had an email from one of my colleagues who wrote a paper using NetLogo and got told that he should use a more serious modeling tool like MATLAB. Quite frankly, NetLogo has already been used for hundreds, if not thousands, of major scientific publications, and not just for an educational perspective, right? And I do believe it has great scientific value. One other small note on that space is that one of the nice things about NetLogo, as opposed to MATLAB or SAS or any of the commercial tools, is that NetLogo is open source, right? In the end, the only way we have to verify or trust that something like SAS or MATLAB is actually working correctly is to trust in the validity of what the developers tell us. Whereas NetLogo, we can actually pull down the source code and look at it and figure out what it's doing, right? So for me, at least, that provides an additional level of truth and validity of a scientific method, right? Okay, anyways, go on with the question. That's a small set. I would like to discuss these types of questions as the field of complexity and complex system continues to merge. And so, anyways, the idea is, like, could we go beyond time series methods? Could we go beyond statistical methods? I think is the question here, right? And the truth is, yeah, I mean, data that you're getting out of NetLogo, right? Data that you're getting out of any agent-based model is essentially equivalent to data that you might be getting out of any scientific experiment to some extent, except that it's within the modeling framework, right? To that extent, you can use as fancy a tool as you want that kind of allows you to analyze the data that you're looking at, right? And so that's very useful in whatever format you want. I honestly think, and I've told many people this, that one of the resources that we're really missing within the agent-based modeling community is a concise description of all these advanced tools that exist, right? And here there are things that have been mentioned that are more, I would say, drawn from a physics background in many cases, mean field approximations, at least a dynamical systems background, renormalization groups, things like that. I actually think that another area that's underdeveloped within the processing and analysis of agent-based modeling is machine learning tools, right? And that's an area that's much more familiar to me. And as you saw from the previous unit, right, that's something that I spent some time researching. So I think it's important to think not only about how to analyze data using traditional statistical methods, but also to use more complex methods that exist. As opposed to like what's the proper tool to analyze a complex system, whether it be bifurcation analysis or not, something from dynamical systems as opposed to agent-based modeling. Well, I think that's really up to your expertise in terms of your modeling techniques. It's also up to which model provides the most parsimonious description. And we're going to talk a lot about that. In fact, we already did in units 4.1 and 4.2 about the fact that it's really, really important to build a simplest description as possible for agent-based models. And not just for agent-based models, for any model for that matter, right? And there's a lot of evidence that having simple models provides us with a deeper understanding of what the model is actually telling us. Okay. So, yeah, so that's a quick answer to that. It's not as useful maybe as some of the more in-depth analysis that you might have liked if we had gone into exactly what was going on with all these details there. And I apologize for that. But as you said, it's a little bit beyond the scope of this particular course to really go into advanced methodological and methods for analyzing agent-based models. That would be a follow-up course, which I would love to teach at some point. Okay, so another quick question. Another quick question that's come up through some of the emails that have happened is I've gotten a lot of questions about whether or not a particular framework or a particular problem is appropriate for study via agent-based modeling. And the truth is that I think almost all the emails I've gotten about this are actually appropriate, right? They actually are about that you can find a way to model the system that you're looking at. One thing I would highly recommend, and this is something I emphasized in the most recent unit, right, is you might have this great idea about a very complex model that you want to build, and that's fantastic, and I really love that idea. But a lot of the art of agent-based modeling or of modeling in general is in trying to figure out what are the essential elements of that model that I need to really use to understand a question I have at hand, right? And so this involves trying to piece down a particular model to look at what are the most core concepts involved in it. So I've had some questions about commuter models, for instance, right? And trying to figure out how should people get to a public transit station? How quickly can they get there, right? And people want to throw in things like whether or not there's restaurants along the way and stuff like that. And I highly recommend, just starting with as simple as possible model, just looking at, one agent or a group of agents moving from a starting point to a finishing point, and how they might make decisions about how they're going to choose their route along the way, right? And try to keep paring your model down until you have some nugget that you think represents what's of interest to you, right? And I think that's vitally important to do. This one here was the most recent email was about understanding eating behavior that I received, right? And that seems like a great idea, but rather than trying to throw in all the things like what diets are out there, what fads are going on, what kind of socioeconomic pressures the individual might go in, you might kind of pare down to just whatever you think is the most relevant aspect for that particular question that you have that you're interested in looking at, right? Okay. So I have a question, or sorry, it looks like John has actually joined us on the call. So hi, John, how you doing?
Hi, Bill.
Good. Well, great. Glad you could make it. I saw you originally clicked on the other link, but yeah, that's understandable. So did you have any questions or comments about the course so far?
I'm enjoying it very much.
Okay.
I was interested in the different significance of the spatial display for different models. Mm-hmm. Like for some, the spatial, where things are in the square is very significant, like in the forest fire. Whereas for other ones like El Farol, there's really just two spaces. Mm-hmm. And where they are within the two spaces doesn't really matter. And I was also thinking about ways to use the space to signify something else, like age or something like that, where they are right to left or something like that.
Right, right. I think you've hit on a great important concept within NetLogo, and and I mean, this is not just NetLogo, this is agent-based modeling in general, right? Is that often and I mentioned this briefly during either one of the lectures or one of the office hours, right? But often agent-based modeling was originally done from a spatial perspective, right? So like the forest fire model, where the space actually meant something within the overall system, right? And a lot of the original agent-based models had that to some extent. Like if you go back, so one of the previous office hours, we talked about the Sugarscape model, which I'll mention at some point along as we go forward. And there was this great book called Growing Artificial Societies, and in that model, they actually had space meant some distance that the agents had to traverse in order to exchange spices or whatever in order to survive, right? And so that was kind of the original, in many cases, that was the original use of space in the agent-based models, right? There was actually a physical space. But in reality, I think nowadays there are actually at least 3 different uses, and you've highlighted them, right? One is that physical space use, where you actually are using the space to represent a physical distance of some sort that you're trying to traverse. The second is, I would classify as the thing you talked about like age, right? Which is, in this case, is moving the space that's represented in NetLogo into a feature space of some sort, right? And this feature space could mean that you're just using those 2 dimensions to represent different aspects of the features of the agents, right? So that you can illustrate that. Right. So, for instance, I just have been working on a model on company innovation, right? And in my model, right, the x-axis represents how far away from the customer's ideal point the company is. So the farther to the right they are, the less the product that the company is developing matches the customer's perfect ideal point, right? And then on the y-axis, we actually represent the speed with which the product gets released in some of the model simulations we've run, right? And so the higher the company is, the faster it is at releasing a product, right, within the simulation, right? And so the ideal company, of course, is like in the upper left corner, which indicates that it's releasing as fast as possible with the best quality product, right? But what we look at is we try and see, well, is there a trade-off between speed and quality that we observe in terms of, how quickly they can innovate? And so in that case, we're using the visual space as just kind of a visualization of an underlying feature space, right? If that makes sense.
Yeah.
And then the third one I just want to briefly mention is I would call just use of the space is just a pure visualization where the space doesn't really denote anything, right? It's just the distances, don't denote anything, right? They're just using the space to visualize some sort of output of the model. So the L for all is a great example of that, right? In the L for all, we basically have the world outside the bar and we have the bar, and all of the space is doing is just connoting, whether or not an individual is in the bar or didn't go to the bar that week, right? And it really is not like where exactly someone is in the bar doesn't matter, where someone is outside the bar doesn't matter. It's just indicating what the status of those individuals are, right? And you'll see that as a third use. So those are the 3 ways space is often used within agent-based models. I would be remiss if I weren't to mention that, the original notion of this physical space has since been supplanted in a lot of models with some sort of network space, right? And we're going to talk a lot about that in this unit because we're going to be talking about how to construct a model of diffusion on networks this unit, right? And so that's going to build a network space. And so that's why a lot of times the physical space is now completely ignored, and instead the physical space now just represents maybe an indication of how far two individuals are from each other across some sort of network that might be connecting them.
Right.
So does that help answer your question?
Yes, thank you very much. Yes, I'm having some trouble with my video, but thank you.
Okay, cool. Yeah, and you know, it's interesting. I don't think that is spelled out anywhere specifically in the course or in the textbook, because it's kind of one of these questions that lies at the intersection of visualization and the environment, right? And of the agent-based model. And so we don't really devote any particular time to that intersection, but it's something that maybe we should talk about, and maybe something to be included in future versions of the textbook as well as the course.
Yeah.
Awesome.
Thank you.
Yeah, cool. Was there anything else you had right now, or should I go back to looking at some of the other emails that came in?
Oh, please carry on with the other ones.
Okay, fine. If you come up with something, let me know for sure, John. So, you know, on a small administrative detail, I had a couple of questions about the upcoming deadline to pay for the tuition, right? And just so you're all aware, the reason why we're doing this is going forward, we're going to be doing peer reviews to grade some of the assignments, right? And the way that works is that you'll submit an assignment, and we'll be doing at least 2 of these and maybe more. The first will be a design document where you kind of describe the basic model that you're building. And this will be similar to the design document you did back in week 2 of the course. But now you've had a little bit more experience building models. I want you to revisit that design document, right? And you'll submit it, and it will be looked at by your peers, right? And that will be, you'll see that assignment sometime towards the end of this week. And the way that works is that once you submit that design document, it'll be sent off to a group of your classmates. And you'll receive some of these too once you submit that design document, right? And you'll be asked to evaluate whether or not they've answered the questions. I'm not asking you to tell them whether or not it's a good model or not, though I will provide a kind of blank entry feedback form that you can fill in, right? But in terms of the grading, you'll just be asked, you know, whether or not they've met certain rubric guidelines, right? Did they describe the types of agents, for instance, right? Did they describe the properties those agents would have, things like that? And you'll just check off whether or not they describe those. And if they've done all those things, they'll get a full grade on that assignment, right? And this assignment counts the same way one of your exams counts, right? So if you're working towards a certificate in the class, overall, between all the assignments and the exams, you need to have a 70% average in order to get the certificate for the class, right? Anyways, because of that, so because those assignments are now peer reviewed, I need to start making sure who is actually going to be completing the course all the way out and who isn't, so that we can send out the assignments to those people who are planning to stick along with the course and follow it through, right? And as a result, we're gonna have a deadline of September 1 for paying tuition, so that we can make sure that we kind of lock down the registration somewhat for the class at that point. So that deadline is coming up. If you haven't paid, you can pay then. Of course, if you don't want the certificate, if you don't want to take the course live with us right now, then you have the option not to pay the tuition, and the materials will always be available for free for anyone who's registered for the course. But you just won't be able to do the peer review assignments. You won't be able to get the certificates and things along those lines, right? So that's the way the tuition works, and you should see a page right when you come to the major agent-based modeling complexity explorer. Right when you go to your lectures and you start looking at it, you should see an ability to pay the tuition. If you don't see that for some reason, or if you don't see those options, please let us know and we'll provide you with a way to pay the tuition. So thanks for those questions. Okay, I have one other question that was, so I've had a couple questions about closed captioning, and I do want to briefly mention our subtitles. We love to have subtitles and closed captions for our videos, but those are done by volunteer effort. We don't have the financial resources here to do those ourselves. So if you're interested in that, please email either admin@complexityexplorer.org, which is probably the quickest way to get involved with that. And if you subtitle, caption some of the videos, I believe they're still offering tuition credits for future Santa Fe Institute courses, right? So that's a great way to do it. But I can't just, unfortunately, I can't just make them available because we don't have the resources here to do that. But we're happy to provide people with benefits who are willing to do that for us. I had another question about for the office hours. So someone was trying to modify the flocking model to make the birds fly around obstacles in the screen. And the code, they were saying, doesn't work very smoothly because of the fact that it just takes a lot of calculations for it to run. And actually, interestingly enough, in Unit 5, we're going to be discussing optimization of code. So this question's a little bit before I want to dive into it too much. But I do want to mention a couple of things that you might have seen that would affect how quickly a model runs. And one of the things that that you often have problems with when having a model that runs too slowly in NetLogo is that it can be easy to overuse ask, right? And so this is something you should think about. When you do an ask, you're asking all the agents to do something. So every time you do an ask, the computational complexity of your model increases by at least the number of agents you have in your model, right? And I should be clear. This is when you're doing an ask, like ask turtles or ask a particular breed, not when you ask, ask turtles with speed greater than 5 or something like that, right? That's actually asking a subset of them. But when you're asking a whole group, you're causing a lot of additional computational complexity to creep into your model. And in Unit 5, we're going to talk about a couple of particular cases as to how you might make that more efficient. One thing you can do, for instance, is if you have a calculation within an ask that every single agent is going to get the same answer to, or that you want them to get the same answer to, then you can do that outside the ask, right? Create a local variable using let to put the result in, and then access that variable. And that's going to speed up your computation quite a bit, right? So for instance, if every agent in your model needs to know how many green patches are in the world, right? Rather than having ask turtles and then putting in a let number of green patches be count patches with p color equals green, you could put let green patches be count patches with p color equals green outside the ask, right? And then use it inside. And that will really increase the speed with which your model runs. So I've actually pulled up, they actually sent along their code, right? So let me screen share for a second. Screen share, okay. Let me screen share the code that they sent along about how to optimize the model. So again, I'm not sure I'll be able to do this agents to avoid. And sure enough, it seems to be running a lot slower than the original flocking model. So why might that be, right? So one thing I often look at, right, is to look to see if there's some ask, like I said, right away. And so there is, you see right here, there's this repeat 5 ask turtles forward 0.2 move slowly, right? And what's interesting is that this repeat 5 followed by 2 asks just before it means that you have now 7 loops through all the turtles, right? And so if I make this a forward 1 or something like that, that's definitely going to speed up the models a little bit. It's not moving that much faster though, right? So let's see if we can figure this out. We'll leave that repeat 5. Forward 2 is actually a fairly quick command. Oh, display, by the way, we haven't talked about, but display actually forces NetLogo, regardless of what it's doing, to update the display. That actually does usually wind up causing you some computational power. So let's try and comment that out. Still not moving much faster, which in this case I wouldn't expect because we had the speed turned down, so it didn't matter too much. So let's look. Flock. The flock command looks to be similar to the flock command we had before, except for find obstacles, right? And then there's crush, which I assume is going to be something to, to actually crush any turtles that run into the blocks. That's interesting. So just to keep track of that. So that's not going to cause us too much. So going back to the flock, I bet the problem has something to do with the find obstacles command, right? Ah, yes, okay. So very much so. So this command, set obstacles patch with p color equals gray in cone 1060. So let's talk about what this does, right? So patches with p color equals gray, you should all know by now, right? That's going to just return the set of all patches that have a p color of gray, right? And in cone, we haven't talked about, but essentially, and it might be useful to look at the NetLogo definition of in cone. Let's see if I can. I have to switch screens real quick to share that with you. So NetLogo definition of in cone, right, is that it takes an agent set and then takes a distance and angle and returns any of the agent sets, any of the agents in the agent set that are in that cone, right? So one way to think of this is that it's a way of giving the agents a vision cone in front of them, right? And so it's saying that, for instance, take all the patches that exist, right? And find all of the patches that are inside of a 60-degree angle directly in front of me and are less than X number away from me. That calculation, it turns out to be one of the most expensive calculations in NetLogo, right? Because I have to first compute what space is in there, and then I have to do an intersection of that with the actual space. So there's a number of different ways you can speed that up. Let's try a couple of them real quick. So for instance, this is doing the patches with p color equals gray and the in cone right away, and it's recomputing patches with p color equals gray every single time, right? So one thing we could do to speed this up is exactly what I talked about before, which is just pre-computing that. The obstacle isn't changing at all, right? And so we could pre-compute the patches with p color equals gray. So we could, for instance, add a tool which is called obstacle patches, right? And we could add those obstacle patches on. Oh, it's create blocks is what does that. So let's go to create blocks. And we can just say set obstacle patches to patches with p color equals gray. Right? So now we've actually pre-built a patch selection for that. And so we can go back to the find obstacles and we can replace patches with p color equals gray to obstacle patches, right? And the reason why we can do this is because the obstacle is not changing over time. Now, that's only a simplified part of our calculation, but hopefully we'll see some speed up. Maybe it's not obvious at all. The truth of the matter is that there's still a lot of calculations going on because of in-cone. That's going to be a little tricky, right? So how did the original flocking model handle doing things like finding flock mates and stuff. Well, if you look at the find flock mates code, it did other turtles in radius vision, right? And so one of the big differences here is it's actually using the whole circle rather than using around the turtle, rather than just using what's in front of it. One other way you can do this is right now this cone is really big, right? It's looking 10 patches out in a range of 60 degrees, right? That's a pretty big cone. So one thing we could do is see if just decreasing how far out you're looking helps at all, right? And that definitely does, as you see, right? So the speed of the model increases substantially now when we have decreased that in cone. It actually turns out, and what I would highly recommend, is that there is actually something that's much simpler to both of these types of code, which is rather than using in-cone at all, and in-cone is one of these things that you should only be using if you absolutely have to because it's very expensive. Another way to do it, and I'm gonna put that original code back in, but then put it in a comment, right? And so then I'll put in the new one, which was in-cone 160. Another one is you can simply use patch ahead, right? And patch ahead will return the patch that's directly ahead of the current turtle, right? And if you'll notice, if you go to avoid, it actually uses, so they actually had they've actually modified the avoid code a little bit too as well. It actually looks to see what's ahead and then tries to avoid it, right? Which adds additional complications to it. But in the original, let me see, I'll save this one off real quick. In the original flocking model, if we were to go back to that, no, it's going to complain. Right? And you look at avoid, separate, it's called, right? Look at the display. Oh, it did do all that in the original one. Okay. Just need to find that. Where's the separate? Okay. Turn away. Okay. Oh, sorry. Here it is. If the distance between my nearest neighbor and me is less than the minimum separation, then I separate, right? So how does it actually calculate nearest neighbor? Well, it actually takes the flock mate that's closest to it, right? And so this is a little different because of the fact that in this particular context, it can actually automatically find the nearest flock mate as opposed to a patch. But in this case, we're looking for static patches. We can actually use, because in one version of the flocking model that's been written, it used patch ahead to determine if there was a flock, a bird on that patch. So what we can do is we can say, if patch ahead, if color of, sorry, color of patch ahead equals gray, set obstacles patch ahead. And these are just different ways. It depends on how much resolution you want to get. But this will just say the patch ahead is when the turtle is facing, what is the patch it's going to next move into if it were to go forward one step, right? P color of that is just going to return the color of that patch ahead. And so if that patch ahead is gray, then I'm going to set that obstacle is whatever that patch ahead is, right? So now, you have to tell it how far ahead you want to look. So let's just say 1 unit right now, right? So that means if it's going to look 1 unit ahead. So this actually is going to probably run the fastest of all the ones that we're looking at. Yeah, so okay. So here's a problem that I didn't think about. When I built that, right, I was just putting a particular patch into the obstacles, but but the person who had built this code had built obstacles to actually be an agent set and not a single agent. We can fix that pretty quickly by just telling obstacles that this is what's called TurtleSet, rather than just a particular just a TurtleSet rather than a particular agent, right? So now TurtleSet expects this input to be we got a patch instead. PatchSet. I forgot there's separate. There's a separate set for PatchSet versus TurtleSet, right? So so it is a PatchSet, and now if we run this, hopefully, yeah, now it works, and that's actually going to be the fastest and most efficient version of that, right? So when you're looking for problems with optimization, so just to get back to the more general comment I want to make about this, right? You should look for code that is less efficient at running. And one of the pieces of code that's very difficult and in general for NetLogo to run efficiently is any code that's having to query a lot of agents, right? And a lot of in the model. And in cone, in radius, those are both ones that are going to have to do a calculation to figure out what agents are being queried, and then do some sort of calculation for that. And it's not a problem if you're doing it once or twice per model tick, but because this code was running every single tick for every single agent, that expands the computational complexity of the model quite a bit. But great question, very interesting little dilemma there. I guess that came from Eugene, and so thank you very much for that question. I'll email a copy of this to you, Eugene, so you can see kind of the changes I made. And if people want, I'm happy to share this code as well, assuming Eugene's okay with that as well. So yeah. Okay, let's see. Okay. If there's any other questions, by the way, that come up. Oh, I see one that came up in the Q&A. I'm happy to answer those as well. I think I have one more in the email potentially to answer. And also, feel free to tweet as well at me, and I'll try and grab those as they come by. Okay. So here's a question from Edward Krug. There are a series of components expected in a model according to Rails backend build program. Are there model expectations too constrained, or are there model expectations, sorry, too constrained or validly another way to think about modeling? Okay, so yeah, Rails backend Graham have another textbook out there, and they talk a lot about what things should be in an agent-based model. And in fact, they both have been involved quite a bit in something that I really like, which is called the ODD, which we'll talk about later. And the ODD protocol is a way of describing an agent-based model, right? And in the ODD protocol, and I'll bring up a kind of an example of it in a second here as I'm talking. In the ODD protocol, they, which stands for Overview, Design, and Details, right? It's a way of describing an agent-based model so that someone else could reproduce it, right? And so it's a very good question as to whether the ODD is too constrained or another way of thinking about modeling. I think it is another way of thinking about modeling. I think it's complementary, and it's in many ways parallel and not in contradiction with what we talk about in this class or what we talk about in the textbook, right? A lot of what I'm going to talk about are ways to think about how you might go about the process of designing and creating a model, not necessarily the process of how to explain how you created that model to someone else, right? I think those are two different notions. Often what the ODD is useful for is after you've built your model, after you have an interesting set of results for it, if you want to go back and show somebody else how to build it or what you found out about it, the ODD is an interesting way of helping you organize your thinking about that, right? You could also use it for model design. I don't think there's anything that prevents you from doing that, but that was not its original intention, and that was not kind of the way it was geared. Whereas what we've been talking about when we talk about things like the ABM design principle, and we talk about the design choices, the 7 design choices, those are things to help a person who is interested in building a model figure out what they need to do in order to build that model. Right. Now, you could use the ODD in the same way to some extent, but as I said, it wasn't created for that. It was created for deciding how you should describe a model, right? I'm trying to pull up a copy of it real quick just so you can see. I think I got it here. So this is the preprint of the original ODD paper. Do a screen share, flip over. I think this is the right window. Let's see. Nope, that's not it. Why are you not showing me the window I want you to show me? Oh, I see. Maybe it's buried back there. Oh, there it is. Okay. Had to scroll down a little bit. Okay. So here is, actually, this is not the original. This is the update of the ODD protocol, right? And I just want to scroll down to show you what it actually is composed of. So the ODD protocol, as we said, it talks about overview, design concepts, and details, right? And in the overview section, you describe the purpose, the entity, state variables, and scales, the process overview and scheduling, and then you get into design concepts, right? And so many of these match up with areas that we've talked about, right? Things like whether or not, are you using spatial units? Are you using an environment? Are you using agents or what agents and individuals? Not are you using, but what agents and individuals are there, right? Describe the process overview and the scheduling. Who, what entity does what and in what order, right? Design concepts. These are things like, is there emergence within your system? Is there adaptation? Is there interaction between the agents? What kinds of stochasticity exist, right? How is the model initialized? What is the input data? What submodels exist, right? It's very, very detailed, right? And it is very useful if you are trying to provide a design document to someone else about describing your model, right? And in fact, that's what the goal of it is, right? We provide an updated ODD protocol for describing individual and agent-based models, right? And some of the things I'm going to say are mentioned, right? There are notes of redundancy, right? Within the ODD protocol, it's probably too complex for some simple models. That's for sure. But it still has an advantage. And overall, right? I would say that the ODD protocol is very, very useful if you want to provide a rigorous set of detail to someone to describe the model you've constructed, right? And it really does encourage model replication, right, in many ways because of that fact. I don't think that their expectations are too constrained necessarily. I think that there might be things that are outside of the ODD that you might want to talk about, right, for sure. And they kind of provide some flexibility for that. And I do think it's a valid way to think about modeling. I think that it's different than what we've talked about so far. So far, we've talked about how to design the model, not how to describe that design to someone else, which is what the ODD was set up to do. So great question, Edward, for sure. Thanks for writing that one in. So I think, and let me double check. So nothing's come through on Twitter at all. I've seen. Looking briefly back at the forums as well, and let's see.
I have a question about random.
Oh yeah, sure.
On the heroes and cowards model, there was some very specific runs that had particular patterns based on an initial configuration from the particular seed being specified. And what I was wondering was, if you've got something like that that's very dependent on the initial configuration, and if you see something, can you retrospectively, if you pause the model run, can you find out what the seed that was used if you haven't specified it?
Yeah. This is actually something I have to double check with the developers on. This is something that is probably one of the most frequently requested items within NetLogo. But as the last time I'd looked, it was not available to find out what the current seed was, right?
Okay.
Now, NetLogo is open source, right? So someone could quickly write an extension that would make that available to you, right? And there may very well be an extension out there already, right? And I know it was on their list of things to do, right? But I don't know if that actually has been added to the NetLogo base language yet.
Okay.
Version of NetLogo coming out sometime soon. I'll add that to my list of things to talk to Uri and the group up at Northwestern about and find out about.
Oh, thank you. So on those 4 or 5 special runs of Heroes and Cowards that were shown, someone had run through a whole space of, because there's a lot of possible seeds, or was that just sort of discovered them by accident?
Yeah, actually, so those were all found by Uri Walensky himself, actually. Okay. And Uri loves playing around with models. He really loves, he's one of these people who gets really interested in just trying to find different things. And so I think what he actually did, I could be wrong about this, but I'm remembering because I think we did that almost 3 or 4 years ago, right at this point, right? Okay. But I think he had built a special version of the Heroes and Cowards model that had a slider that could control the random number seed, right? And so you can have a slider that has different number seeds. And then what he would do is when he hit setup, it automatically set the random number seed to whatever the slider value was, right? And then he could run it and then see if he liked the results. And if he did, he could then see what the value of that slider was and then build up the little buttons that you saw below, right? And so I believe that's the way he actually did it. And yes, he did do it by manually playing around with the values and kind of getting interesting patterns that he saw, which, is amazing to me, but it's something Uri loves to do. He loves playing around with models and seeing what they get out of them. So,
okay.
Yeah. Cool. Any other questions about that?
Actually, there was something, there's probably no solution really, but because when you were talking about feature space, in terms, it made me, I was thinking about the problem of superimposed turtles being in the same place, really, and lots piling up in the same place, and whether there was any way to ameliorate that. Yeah,
that is a little bit, you're right. This is something that doesn't have a perfect answer for every single problem you might look at, right? Now in R, actually, interestingly, when you're plotting data, there's a command called jitter. What jitter does is just kind of move the point somewhat away from where it's actually supposed to be. So you could think of it as a false representation of the data, but it kind of is useful at a first glance because what it does, if you have 1,000 points all stacked on top of each other, it just kind of moves them slightly away from that, right? You can see how many points are there, right? So you could write something like that for NetLogo. It's not a built-in command like it is in R, right? But you could essentially write a command that basically looks at each patch and determines if there's a lot of turtles on that patch, which you can do by using the turtles here command, right? And then basically, if there are a lot of turtles on that patch, maybe moves them to some nearby patches or something like that randomly, right? But yeah, you're right. That is a problem, trying to represent how many turtles are in a particular space. Another thing you could do, another way to solve that problem, Something we haven't talked about a lot, but we'll talk a little bit about in Unit 5 is all patches have what are called patch labels, right? And patch labels can be turned on. Let me show you an example real quick. Oh, shoot, that's wrong. Hold on. I bring up the right version now. So I have like the last 20 versions of NetLogo installed, so I want to make sure I have the most recent one. Okay. Not that one. Okay. So file new. Okay. Good. So screen share this. Okay. So in the in NetLogo, right? You can, if you look at one of the patches, oh, and of course with screen share this is going to work because it opens a new window. But if you look at one of the patches, if you just inspect it, you'll see that there's a patch label, and I can actually set the patch label to a value. So here I've set the patch label to 10, right?
Oh, I see.
Yeah, and so it actually shows up on the screen. So for instance, I could, let's see, I could clear all, I could create 100 turtles. I could ask the turtles to move to a random coordinate, right, throughout the world. And I can have the patches set their patch label to count turtles here, right? And now every patch has an indicator, right, as to how many turtles are on that patch. So like this one is the only one I can see that has more than one. It actually has 2. This one has an orange and a green turtle on it, right? Now you probably wouldn't want to do that for every single patch, but maybe you could in fact do, well, let's say set P label. I'll go back to nothing, right? I could say if count turtles here is greater than 0, right? Then set P label to count turtles here. Okay. And now you can see just the ones that actually have turtles on them, how many turtles are there. Yeah. I don't know if either of those is a perfect answer to your question, but yeah, there isn't a best way to do that. I mean,
okay, thank you.
Does that help?
Thank you, yes.
Okay, cool. I have one last question I'll take before we hang up for the day, right? Which, and first of all, Georgios says hi to all as one of the Q&As, so hi, Georgios. But then I have one last question from Edward Krug. In the L for all model, there is a distribution of reward accumulation. Has anyone reported parallels with the wealth distribution in the simple economy? And no one's actually studied that scientifically. The wealth distribution, the L for all model, is not something that's traditionally investigated in a lot of the scientific papers on the L for all model. That was something that we just built because we were kind of interested in it. And so we figured it would make a good example of an extension. But to my knowledge, and I could be completely wrong about this because I don't know every paper on the L for all bar problem, but I have not read an L for all bar problem paper that really investigates the distribution of rewards at the individual level. So Edward, if you're interested in looking into it, that would be great, right? I think there were some comments in the forum that there might be some related, the distributions might be similar, and that they might be a little heavy-tailed, meaning that there's a lot of individuals who do very well in L for all and in the simple economy. There's a few individuals who do very well in L for all in the simple economy, and a lot of individuals who don't do very well. So yeah, definitely something to investigate. Might be worth a project or something to look into. Great question. Okay, well, I think that's all the questions I have for today, and it's now noon, so I want to make sure I end on time. But I want to thank John, first of all, for being part of the call today. Thanks, John.
Thank you, Bill.
And if anyone else has any questions, if you're interested in joining the office hours for next week, please send me an email. Just to quickly recap the announcements at the beginning, units 4.1 and 4.2 are up now. The rest of the units should be up in the next couple of days. But we may be skating a little bit into next week for Unit 4 because it is a lot of content for Unit 4, right? Also, there will be The deadline is September 1 for paying your tuition. And after that, we're going to cut off payments for this course, and those will be the students who will be enrolled for this course. And finally, the last comment was that you should be looking for a peer review assignment at the end of this week to complete. And that will count just as much as one of the exams. Thanks, everybody, and I'll see you all next week. Take care.
Bye.
Bye.